Let's look at doing a masonry takeoff using a very simple floor plan. Step 1, let's take a look at our drawings, understand what our unit of measure is. I can see that this building is 40 feet wide or 40 feet long by 30 feet wide, so I know I'm using imperial units. I can identify that I have some window and door openings shown here. So this is a 48 by 60, so 4 foot by 5 foot window. That's what all the windows are, and a 36 inch by 84 door. So a 3 foot by 7 foot door. Okay, we're doing masonry takeoff, so we're looking for surface areas. So if we want to figure out surface area of this particular building, we need two different things. We need a length of wall, and I need the height of the wall. So the length of the wall I can see right here, 40 plus 30 times 2. So 140 feet. Next I'm going to scroll down and see I have a wall section here, and I have 11 foot 6 for a height for my brick and 9 feet for my concrete block on the inside. So I can do brick area is equal to that 140 times 11.5. $16.10 square feet. Block area 9 feet high, so that, again, same 140 by the 9, 1260. And I can write all this information right here on this plan because I'm working with this plan. You can see it right in front of my eyes here. It makes it easier if we can actually physically write it down right on my plan here and get an understanding of it. Okay. Next, I need to figure out what the area of my openings are, because I need to remove that area from my surface area of my brick and my block, because there's obviously not going to be brick or block covering those openings. Okay, so opening area. Okay, again, we just mentioned we have the windows here, 1, 2, 3, 4 windows, and each one of those windows is 4 foot by 8 foot, so 4 foot by 5 foot, sorry, so 20 square feet. So 20 times 4 is 80. So we got 80 square feet for my windows, and then one door that's 3 by 7, so 21 square feet. So add those together, you get 101 square feet for your openings. So now I can take that information and really transfer it down to my estimate or my civil pad below when I start doing my calculations. Okay, so let's look at doing our brick first. We'll start from the outside. We got a 4-inch standard brick. So 4-inch standard brick. And what do I need? I need to know the area of brick. Okay, I just figured out the area of brick up here was 1610 square feet, and then I need to remove that 101 square feet from that for my openings. Right, so 1610 subtract 101, and again that was my openings. $1,509. That's square feet. So now I need to know how many pieces for every square feet of my 4-inch standard. Go down to my Shaw information here. 4-inch standard, 686 for every 100 square feet. Okay, so that's 6.86 for every square foot times 6.86. Again, that's pieces for every square foot. $10,351.7. We have a 5% waste factor, so we'll add that 5% to it here. 10,070. We always round up the next full piece. 10,870 pieces. Good. Let's do block. Again, I need the area of that block, and then we subtract the openings. So we had 1260 for my block area here, 1260 square feet. Subtract 101 square feet, and again that's the area of my openings, 1159 square feet. Okay, again I need to find out how many pieces per square foot. Go to my Shaw information down here, and they're always the same, 113 for every 100 or 1.13 for every square foot. So times that by 1.13 pieces per square foot. $1,309.67, and again I need 5% waste here, times 1.05, and around the next full piece is 1376. 1376 pieces. So that's for your brick and block total number of pieces. Next we want to move on to mortar. Let's say for our exterior wall, so for our brick, we're using a type S mortar. Okay, so mortar is based on number of pieces. So that would be for our exterior for our bricks here again. So 10,870 pieces. Again, we want to scroll down to our Shaw page here, 4-inch standard brick. We want to use cubic feet per thousand, so 8.06 cubic feet per thousand. Okay, so divide that by 1,000, multiply by 8.06, and that's cubic feet per thousand pieces. 10,870 divide 1,000 times 8.06. You get 87.6 cubic feet, and we don't add a waste factor to that, remember, because we've already added a waste factor to our number of pieces of brick. But I want cubic yards, so I need to divide that by 27. So 3.2 cubic yards of type S mortar. And let's say our interior walls for our concrete block is a type N. Again, I need to know number of pieces, so my concrete block, 1376 pieces. I need to look at my Shaw information to figure out how many cubic feet per thousand of block, and it's 65 cubic feet for every 1,000 block. So again, divide by 1,000, multiply by 6.5. 1376 divided by 1,000 times 6.5. 89.4. Again, cubic feet. We want cubic yard. We're going to take that value, divide by 27. 3.3 yards of mortar. Okay. The next step I could do with this is look at my insulation, my air vapor barriers, and with those you're still going to be using the areas, so just pay attention to where they're located. Your air vapor barrier would be on the inside of your insulation, so if I drew a line up here, your air vapor barrier is basically going to go along this green line here. So that's the same area as your brick. Okay, I'm not going to remove my window and door openings because I don't have any that's over that 40 square feet. Remember we talked about that? We may have talked about that before, or we'll discuss that in class. We're not removing any openings for insulations or barriers unless those openings are larger than 40 square feet. And all these are less than 40 square feet, so we don't bother removing them. So those areas, we can just use that brick area there. So that would be for your insulation and your air vapor. Flashing could be next, so we'll maybe quickly look at flashing here. I've got flashing in this darker red line. So flashing is an area measurement. So I want to know what the length of that flashing is. So if I extend that up about 2 blocks, that's about 16 inches. And we extend out past here. Well, let's just make it for that'll probably be around 24 inches. Right, so if I take 6, another 8 inches, it gets us to 24 inches. So 8 plus, so 24 inches. And next I would need to know the length. So the length of that is it's base wall flashing, so it's going to go all the way around. Okay. Now there wouldn't be flashing at the bottom of my door here, because that, you obviously be tripping over it if it was at the bottom of your door, but there is some above the door, so it kind of cancels each other out there. But then I at my window openings, I actually have flashing above my windows, right? Because anywhere where there's really a break in your wall system, so if I drew this out really quickly, if that was my wall, and you have your window here, right, you're still going to have flashing at the bottom. And you're also going to have flashing above your window opening here, so you wouldn't have water coming down in behind your window. So you actually have extra flashing above your windows. So I need to know my length of my wall then, because I'm going all the way around like I just mentioned, so I got 140 feet. And then I want to know what the length of my openings are as well. So for my windows, I have 1, 2, 3, 4 of them here again. Each one of those windows was 4 feet long, so 16 feet. So really I have an extra 16 feet of flashing. So 140 plus that 16. 40 plus that, right? So you get 156 feet. So let's use that 156 feet for my flashing calculations. Again, flashing. I'm looking for an area here. We're going to be square feet. The length of my flashing was 2 feet or 24 inches, or the height of it. The length around the building was at 140 plus the extra from my windows, which worked out to 156 feet. Okay, so take 156 times the 2 feet. 312 square feet. There is a 5% waste factor, so we'll add that in here. 1.05. Let's just say 328. 328 square feet of flashing. Next, we could look at our weep holes. And really the same thing is true with our weep holes as our flashing, because remember we always have, if we have flashing, we have weep holes. They go hand in hand. So if I look at my wall layout here, I wouldn't have any at the bottom of my door, because again, you'd be tripping over them, but I do have them at the top. So that kind of cancels each other out. And at our windows here, I have extra ones above my window going along here. Okay, so really, for my weep holes, my weeps, which were every 32 inches on center, it's that same length I have for my flashing. Same length. So take my 156, divide by 32 inches, and 32 divided by 12 is 2.67 feet. 2.67. 156 divided by 2.67. 58.4, so we round up to 59. You should do plus 1, so you get 60 weep holes. That's pretty good for this wall section here. Next step would be go ahead and add some reinforcement. We can do that in the next one.